Okay, so we are going to fill out this table based on how we write ionic formulas. Or ionic compounds. Ionic compounds must be neutral. Therefore, the charges must be equal. They must equal 0. So whenever you are writing an ionic compound, you want to make sure that the charges add up to 0. So aluminum and sulfur, aluminum has a charge of +3, sulfur has a charge of -2. You're going to need 2 of these to make +6. You're going to need 3 of these to make -6. So when you add those two together, you get 0. And the quickest way to take care of this math without making any silly mistakes, because everybody knows you make silly mistakes when you're stressed, especially on chemistry tests and you've been, I don't know, cramming all night. So what you can do is do the cross and drop. So this means you're going to get Al2S3. This is the formula for aluminum sulfide, and it's correct because the charges balance. So let's try another one. Write the formula for the ionic compound that forms between barium and sulfur. So barium has a charge of +2 or 2 plus, sulfur is 2 minus. So it's a 1-to-1, so it's just going to be BAS. Now, if you did the cross and drop method, Ba2S2, you can simplify that so you end up with BAS. So when writing formulas, you must write the cation first. Remember, the cation is the ion that has a positive charge. Omit charges. Ionic compounds do not have charges. Use parentheses when more than one polyatomic ion is present. Now, I have students who love to use parentheses. They over parenthesize. I have other students who under parenthesize. It just depends on where you are in the process. So be aware if you're an over parenthesizer and under parenthesizer, check your work. You only use parentheses when you have more than one polyatomic ion present. So if you have ammonium chloride, no parentheses are needed. But if you have NH4 ammonium sulfide, then you're going to need parentheses because this is a -2. And in order for this +1 to be +2, you need to have 2 of those subunits. Now remember, ionic formulas are the simplest ratio of ions, so that's why Ba2S2 doesn't work. Okay, now I know we've gone over this before, but it never hurts to repeat it. So on to page 11. On page 11, I have you practice a lot of formula writing. So what you're doing is the cross and drop for each one of these. So I have a +1, -1. This is just going to be NaCl. +1, -2. I'm going to cross and drop that. And if you want, in the beginning, you can do the cross and drop, bring it down above that. So you get Na2CO3. Let's go to number 21. Calcium hydroxide. So you're just going to do the CaOH2. Now, why did I use parentheses there? Because I had more than one polyatomic ion. Okay, so +1, -1, NaOH. You are going to do this for all 66 of these. And you think, oh my gosh, 66, that's so many. It's such great practice. I encourage you to hit pause right now, do all of these, and then double check these with me. When you come back, I will have these all filled out. All right, so what you end up with, Na2SO4, Na3PO4, NaNO3, NH4Cl, NH42CO3, NH4OH, NH4SO4, NH43PO4, NH4NO3. KCl, K2CO3, KOH, K2SO4, K3PO4, KNO3, CaCl2, CaCO3. We did this one, CaOH2, CaSO4, Ca3PO42, CaNO3, MgCl2, MgCO3, MgOH2, MgSO4, Mg2PO43, MgNO3, ZnCl2, ZnCO3, ZnOH2, ZnSO4, Zn3PO42, FeNO32, FeCl3, Fe2CO32, FeOH3, Fe2SO43, FePO4, FeNO32, AlCl3, Al2CO33, AlOH3, Al2SO43, AlPO4, AlNO33, COCl3, CO2CO33, COOH3, CO2SO43, COPO4, CONO33. FeCl2, FeCO3, FeOH2, FeSO4, Fe3PO42, FeNO33, HCl, H2CO3, HOH, H2SO4, H3PO4, HNO3. Yeah, just like that. Okay, so on to the next page, naming. Naming ions. So, cations. Remember, cations are the positively charged ions. You can remember that because cations have a T or a positive sign. Metal group ions, groups 1, 2, and 3, are named by listing the metal followed by ion. So this is potassium ion. That would be +1, +2, +3. So magnesium ion. That kind of ran together. Should be a space right there. Magnesium ion, and then aluminum ion. So your main group. Your main group metals, you just list the metal name followed by the word ion. Pretty simple. Now, transition metals, these are not main group. Those are the ones that are in the middle. They, remember your transition metals right here. So your transition metals, you add they can have different charges. So that impacts how you name them. So they can vary in charge. So the common way, which is the older way, is to add a lower charge, add OUS to the ending. Higher charge, add IC to the ending. So for this example here, you could have two charges on chromium, +2 and +3. So chromous ion or chromic ion is the common way. IUPAC is the newer way, and IUPAC stands for the International Union of Pure and Applied Chemistry, where a big group of people get together and they talk about how they're going to name these compounds. It is a very important job. It seems silly, but it is very important because publications, you need to make sure that you're talking about the same compound. So if you use a different nomenclature than somebody else, it's not going to be clear. Sorry. So chromium, Roman numeral 2 ion, and then chromium, Roman numeral 3 would be the IUPAC. Now, anions, those are the negative charge. Anions are named by replacing the ending of the element with IDE followed by the word ion. So this it's not mean, it's bromide ion, oxide ion, sulfide ion, nitride ion, phosphide ion. Okay, so naming ionic compounds. There are two ways to name them. You have ionic compounds, you have main group metal bonded to a non-metal. And then the other option that you could see is a transition metal bonded to a non-metal, or any polyatomic ion, both of those. So you can have this. That would be lithium fluoride. Transition metal, something like this. This would be chromium 2 chloride. Okay, so there are metals that form more than one charge. These are your transition metals, I should say. Transition metals. And they use, you see them a lot more with the common nomenclature, and it's important that you know these. Ferrous, ferric, this is the lower charge, +2. This is +3. Cuprous, +1. Cupric, +2. And this is the little number that I'm getting off the periodic table. Let me show you in just a second. So this is when I joke around that it would be nice to have a periodic table tattoo. Let's see. Which one we were working in? Copper. If you look at copper, sorry, this is shaky. If you see these two little numbers here, those are the two possible charges. They could be +2 or +1. Iron could be 3, 2, or 6. We don't see 6. You can cross out 6. Let's see. Gold. Gold is right here. Atomic number 79. 3 and 1. So it could be +3 or +1. So these little numbers tell us what you could have possible charges. They're really handy. And if you get this periodic table, which I'm very partial to, this is the periodic table that we use in principles. Principles, when I say principles, it's Chem 122. If you go on to Chem 124, they might not give you this periodic table. This periodic table contains a ton of information. But one thing I love it for is the transition metal charges. Now, you have been warned. Only use those numbers for the transition metals. Do not, I repeat, do not go over here and say, oh, I wonder what the charge is on oxygen. I'm going to look at that. And you look at the little black numbers, and it's like, what? -2 or -1? I thought oxygen was in group 6, and it's always -2. It is in group 6, and it's always -2. It's not a transition nonmetal. So only look at the numbers, those little tiny numbers for the transition metals. I mean, if you look at bromine, oh my gosh, so confusing. There are 4 numbers. How the heck would you name that? It's crazy. So, you only use those little numbers for the transition metals. Don't use them for the main group metals. This is +1, this is +2, and this is +3. So you've been warned. Oh, and this -3. Okay? Now, back to what I was talking about. Okay, Orus is going to be Au +1, Auric, Au +3. Stannous is going to be Sn +2, stannic, Sn +4. Plumbus, this is lead, Pb. Where are you, Pb? Oh, your atomic number 82. So C +2 +4. So Pb +2, Pb +4. Chromis, Cr. I want to make sure. You could be 3, 6, or 2. So it's just 3 and 2. 3 and 2. Okay. So +2, +3. And mercurius, mercuric, Hg, 1 or 2. Oops, sorry. Okay, so ionic compounds are named by listing the cation name first, followed by the anion name. Note, the word ion never appears in the name of the compounds. Okay? So, we have some practice problems. This is going to be magnesium carbonate. This one is going to be ammonium sulfide. Oh, what's this? A transition metal? You have to use parentheses or use your us and your ick. So this could be, it's copper sulfide. And which copper is it? It's a mystery, right? So if you don't have a subscript, assume it's 1. So you're going to do the cross and raise. So it's copper 1 sulfide, or you could name it cuprous sulfide. I do have students that I like to think of them as my old souls. They really like to use the common nomenclature, and I respect that. They like the us and the ick. I don't know what it is about it. They find it charming, but I'm glad. So you might be one of those students, or you might be a student who hates it and thinks, I'm not going to learn this because, yeah, I'm just going to use the Roman numerals. Be aware that on an exam or a quiz, I could say, what is cuprous sulfide? And you would need to answer that. Okay, so this is iron 2 acetate or ferrous acetate. How did I know it was 2? I raised up that 2. Okay, this is tin 2 phosphate. Oh, phosphide. It's not phosphate. That's a good mistake that I made. PO4 is phosphate. P and PO4 are very similar, but they are not the same. Tin or stan. No, it's not stannous. It's stannous phosphide. Okay. Our next one, copper. I'm going to show you. It's going to be plus 2, HCO3 minus. So it's copper 2 bicarbonate or cupric bicarbonate. Okay. The next one, Fe plus 3 iron 3 oxide or ferric oxide. And this is ammonium dichromate. If you don't know your polyatomic ions very well now, it's going to really show up on a question like this. So be careful. So remember, metals metals lose electrons to form cations. Nonmetals gain electrons to form anions. All right. Now on the next page, I wanted you to name all of those formulas that we'd written previously. So remember, this is from page 11. It shouldn't say 4. Page 11. I wanted you to go through and name all of these. So number 1 is NaCl. How would you name that? That's sodium chloride. All right, so question 2 would be sodium carbonate. And so on and so forth. So these are to be filled out. I want you to hit pause and name those. It's good practice for you. And then we have even more practice for you on the coming pages. All right, so I'm going to go over these. Sodium chloride, sodium carbonate. 3 is sodium hydroxide. 4 is sodium sulfate. 5 is sodium phosphate. 6 is sodium nitrate. 7 is ammonium chloride. 8 is ammonium carbonate. 9 is ammonium hydroxide. 10 is ammonium sulfate. 11 is ammonium phosphate. 12 is ammonium nitrate. 13 is potassium chloride. 14 potassium carbonate. 15 potassium hydroxide. 16 potassium sulfate. 17 potassium phosphate. 18 potassium nitrate. 19 calcium chloride. 20 calcium carbonate. 21 calcium hydroxide. 22 calcium sulfate. 23 calcium phosphate. 24 calcium nitrate. 25 magnesium chloride, 26 magnesium carbonate, 27 magnesium hydroxide, 28 magnesium sulfate, 29 magnesium phosphate, 30 magnesium nitrate, 31 zinc chloride. No 2 because zinc only has one number listed for the transition metals. Okay, so even though it is a transition metal, see, there's just one number written right there. So it's just zinc chloride, zinc carbonate, so 31 is zinc chloride, 32 is zinc carbonate, 33 is zinc hydroxide, 34 is zinc sulfate, 35 is zinc phosphate, 36 is zinc nitrate. All right, iron 3. This one has more than one charge, so you need to put Roman numerals or arsenic. So 37 is iron 3 chloride, 38 iron 3, it should be a 3, carbonate, 39 iron 3 hydroxide, 40 iron 3 sulfate, 41 iron 3 phosphate, 42 iron 3 nitrate. Got another error. Good thing we're going through these, right? All right, 43. Aluminum is not a transition metal. Therefore, you do not say what the charge is. Aluminum chloride. 44, aluminum carbonate. 45, aluminum hydroxide. 46, aluminum sulfate. 47, aluminum phosphate. 48, aluminum nitrate. 49, cobalt is a transition metal. It can have a charge of +2 or +3, so you do need to put a charge. So 49 is cobalt 3 chloride. 50, cobalt 3 carbonate. 51, cobalt 3 hydroxide. 52, cobalt 3 sulfate. 53, cobalt 3 phosphate. 54, cobalt 3 nitrate. 55 deals with iron 2. Iron 2 is a transition metal. It can have more than one charge. Therefore, you need to have a Roman numeral. 55 iron 2 chloride. 56 iron 2 carbonate. 57 iron 2 hydroxide. 58 iron 2 sulfate. 59 iron 2 phosphate. 60 iron 2 nitrate. Fix that one too, so that should be 2. 61 HCl, so hydrogen chloride. 62 hydrogen carbonate. 63 water. 64 hydrogen sulfate. 65 hydrogen phosphate. 66 hydrogen nitrate. Okay, so on to page 17. Name the following compounds according to IUPAC convention. So these are just the rules that we've been going over. I'm going to list these for you. This is a good time to hit pause, practice these, and then come back and I'll go over the answers. Okay, so number 1 is calcium carbonate. Number 2, potassium chloride. Number 3, iron 2 sulfate. How did I know iron was +2? Because I know my polyatomic ions. Make sure you know the charges on your polyatomic ions. SO4 is -2, therefore iron must be +2. Number 4, lithium bromide. Number 5, magnesium chloride. Number 6, iron 3 chloride. Cross and raise. So I raised that 3 up, so I knew that the iron was +3. 7 is zinc phosphate. 8 is ammonium nitrate. 9 is aluminum hydroxide. 10, copper 1 acetate. If you missed that one, get to know your polyatomic ions. Okay, 11, lead 2 sulfate. Sulfite. I said It's sulfite. Number 12 is calcium oxalate. Number 13, iron 3 oxide. Number 14, ammonium phosphate. Number 15, magnesium nitrate. Number 16, copper 2 sulfate. Number 17, sodium bicarbonate. Number 18, nickel 2 bromide. No, nickel 3 bromide. I have the correct thing written, said it wrong. Number 19, beryllium nitrate. Beryllium's a mean group. You do not need to put a Roman numeral. It's not a transition metal. Number 20, zinc sulfate. Number 21, gold 3 chloride. And there you go. Practice, practice, practice. It never hurts to practice with this material. All right, so that concludes this section of Unit 2. If you're rusty on your polyatomic ions, I was joking around earlier, but you really need to know them. It will help you so much. All right, until next time.